we are coming up to our last speed talk of the day from Riley Knoedler, and they are going to be talking to us about BatCopter, which is a custom-made drone for bat surveys with novel AI workflows. Whenever you're ready, Riley.
Okay, great. Okay, so I'm Riley. I'm a data scientist at Western Ecosystems Technology, or WES. And so let's just dive right in. Even if you're not familiar with bats, you probably can guess that they're being negatively impacted by things like climate change and habitat loss. In North America, bats are facing lots of challenges from white nose syndrome. And then here at West, we focus on impacts of renewable energy. And so bats also run into wind turbines, unfortunately. And there are a lot of existing solutions to monitor bats. One of the challenges with passive acoustic detectors, which are frequently used in this space, is that if you have a detector out all night and you hear under 100 calls, it's not necessarily clear whether that was 100 bats that flew by or one bat just circling your detector. And so we wanted to develop a solution to more comprehensively monitor trends in total bat population in an area. And so that was the birth of the BatCopter. So the idea is that you have a drone that has a thermal camera, but hanging from it also has an acoustic detector. And if you fly transects with the drone faster than bats fly, you can count the bats in an area, avoid double counting, cover a much larger survey area, minimize your actual interaction with bats, and this can enable estimations of an abundance index in an area. This work's been going on for more than 5 years. So we started using DJI drones, which are Chinese manufactured drones. But we observed that we were hearing with that acoustic detector fewer low frequency bat calls than we were picking up on the passive acoustic detectors in the same study areas. And we hypothesized that that was because the noise of the drone was actually interfering with picking up those calls. And so because of that, and also because there's a lot of pressure in the United States to not use Chinese-made drones, we partnered with Persimia LLC to make a fully American-made drone. And so this BatCopter has some cool engineering specifications. Its arms are further apart. Its blades are pitched at sort of a slightly different angle and made of different material. And it also uses LiDAR instead of ultrasound to detect obstacles as it flies. And so all these things reduce its noise and also decrease its interaction with bats. And so we've been doing field trials last year and this summer. And then I've been working on our AI to actually analyze all the data we're collecting, because we have both the videos and all of the calls. We have our own in-house bat call classifier called SpectroVision, which I won't get into today, but I'll talk a little bit about processing the thermal videos. So if you have done any work in computer vision and trying to track objects, you are probably familiar with the idea that to follow something in a video, you find it and then you track it sort of frame by frame. But that's really hard in this context because the things are so small. So for example, there are 2 birds in this image and they're right there. And so our human brains or neural networks are, using the context of how the birds and bats move in the video to be able to follow them. And so the AI pipeline has multiple steps to try and make this more workable. So we use background subtraction based on how the drone is moving to highlight the objects that aren't stationary relative to the ground. And so you can see that there's a bat that flies across in the bottom right corner here. And then we've transformed the video, and it's much easier to see actually on the bottom right in this transform version, where it's like 2 white dots following each other. So now we can apply more traditional computer vision methods like object detection and object tracking. So we use an object tracker, but it has some false positives that come through it. So you can see the blue box on the left is following the bat, same as on the right. But then there are these false positive boxes that are still appearing. And that's just because this method isn't perfect. You still get highlighted things like a hot cow pie on the ground might look like a little hot thing that the drone will pick up, or a rabbit. And so we have a final step or penultimate step of track classification. because a lot of the false positives, if they are stationary, just look like a line kind of going down the screen. And so we're able to segregate out the false positives from the true tracks, but the algorithm still doesn't know if it's a bat or a bird or, a rabbit hopping around. And so we do have a human in the loop element where there's expert review. How does it do? So these are really cryptic species, and they're not very abundant in the areas we're studying. So we had a person manually review 1,200 videos, and they found 19 bats. And then we used our AI pipeline, and it found 20 bats. But the interesting thing here was that the 19 wasn't a subset of the 20. So actually, there were 14 bats that both systems found, a human watching them all, and then the AI pipeline. And so there were 5 bats a human found that the AI missed, and 6 that the AI found that the human missed. And then, of course, some number that both systems missed, and that's sort of the biggest challenge, I think, with this system is we don't know, and it's hard to estimate what we're missing that's flying around there. But yeah, we're really excited about this system. Obviously, AI can process these videos faster and get rid of a lot of the empty video, but also I think a more subtle benefit is that the AI is going to perform the same kind of errors more consistently, whereas every time you have a new human reviewer that you train, or a human reviewer that's been watching these videos for 1 hour versus 5 hours, they might have more differing error rates. And so this is going to enable more sort of robust statistical estimation over time. So yeah, I just want to shout out the other people involved with this project at my company. Persimia LLC is actually the drone manufacturer that we partnered with that did the engineering. And then this work was funded by Berkshire Hathaway Energy and Mid-American Energy Company. I didn't have time to get into any of the actual stats for estimating abundance, but if you want to follow up on that, let me know.
Thank you so much. Yeah, I feel like this was such a good teaser for what could hopefully be a longer talk eventually, because I'm left wanting more and also have so many questions because I think a lot of this is totally beyond my expertise level. And we do have some questions in the chat. One from Henry is raising his hand very politely. And I know he's a big Bat fan, so I might actually let him ask his question himself because he's a big Bat fan.
So I think, we haven't seen any issues with collisions in all the surveys we've done, and the drone is flying 40 meters up. But yeah, certainly you wouldn't want this to actually lead to a collision, but it hasn't happened yet.
Thank you very much. I did actually have another question as well. That was really, really cool. Thank you. I really want a BatCopter. Do we know what the rough sort of cost per unit might end up being?
So I think that the R&D that went into it was in the range of $500,000. And so at this time, I don't think that it's going to be open source yet. But if you want to get in touch and talk to us about, how we can partner with you, definitely reach out. So, yeah.
Amazing. For just to keep us on track for time, if anybody else has questions, feel free to pop them in the chat, and I'm gonna tell Riley to get in there and get those answers. I'm seeing one from Morgan. I think I see Bree having her hand up, so feel free to write those questions in the chat.